can write the area of this triangle ABD. Okay, so area of this triangle, area of ABD is equals to half of area of ABC. We can write area of ABC. Okay, because the area of this triangle and this triangle are equal. In this problem, we have P is a point in the interior of a parallelogram ABCD. Okay, so this P is the any point. P is a any point in the exterior, in the interior of the parallelogram ABCD. Okay. Now we have to show that area of APB, area of this APB, this triangle, plus area of this triangle PCD, okay, these two triangles, area of APB, area of PCD equals to half of the area of the whole parallelogram ABCD. Okay. Now the second equation is area of APB plus area of PBC, all right. So area of this triangle and area of this triangle, area of this triangle plus area of this triangle is equals to the area of APB, that is area of this triangle, and area of PCD. Okay. So how we are going to do that? Similar to the previous problem, we have to do a construction here. All right. So what is that construction here? Let's take EF as the midpoint of AD and BC, and we have to join EF. Okay. So now EF is parallel to AB and also parallel to CD. All right. So we divided the whole parallelogram into two parallelogram of equal area. Okay. But we have to go from the point P. We have to go through the point P. Okay. Now, similar to the previous problem, we have the theorem. The area of a triangle is equals to the half of the area of a parallelogram if both of them are between the same parallels and in the same base. So now this APB and parallelogram AEFB, they are in the same base AB, okay, and between the same parallel AB and EF. Okay. So we can write area of APB equals to half of area of AEFB. All right. Now similarly, in the lower part, the area of this triangle PCD, area of this triangle is half of the area of this parallelogram, this one parallelogram. Okay. So here we can write area of PCD equals to half of area of EFCD. Okay, EFCD. All right. So let's take this equations 1. Let's take this equations 2. All right. So area of this triangle is equals to half of the area of this parallelogram, and similarly area of this triangle is equals to half of area of this parallelogram. All right. So from 1 and 2, if we put 1 plus 2, all right. So area of APB, area of PCD. Okay. So equals to half of, if we take half common, okay, if we take half common here, area of this parallelogram and area of this parallelogram, if we add them, what we will get? Area of ABCD. All right. So we have proved the first question. Okay. Now according to the second question, similarly Okay, here similarly, since we proved that area of two interior triangles are equal to the sum of the area of two interior triangles are equals to the half of the area of the parallelogram. Okay, first this one we have proved. Now similarly, if we take this APB, okay, this triangle APB, this triangle, and similarly PBC. Now if we take these two triangles, this triangle and this triangle, all right. So according to this criterion, that area of the sum of the area of two triangles are equals to the half of the area of the parallelogram. So if we consider similarly these two triangles, we can write that area of APB plus area of PBC, okay, equals to the half of area of ABCD. All right. So we already have that earlier one, okay, that half of ABCD is equals to APB equals to PCD. Okay. So in place of ABCD, we can write this one APB equals to PCD. Okay. So that is the only thing we need to prove. So the area of these two triangle is the sum of the area of these two triangle is equals to the half of the area of the parallelogram, and we already proved that area of these two triangles, area of this triangle and this triangle is also equals to the half of the area of the parallelogram. Okay. So if it is equation 1 and if it is equation 2, from 1 and 2 we get that area of APB, PGB, the second question also we have proved. All right. This is also a similar problem. Okay. So here we have two parallelograms PQRS, okay, this PQRS, this one, and ABRS. Okay. So we have two parallelograms and X is any point on side BR. So this X is any point of this on this side BR. Okay. So we have to show that the area of PQRS, okay, so area of this triangle, this parallelogram PQRS is equals to the area of this parallelogram ABRS. Okay. So we already have that theorem, the area of two parallelogram between the same base, between the same parallels and in the same base are equal. So definitely the area of PQRS is equals to area of ABRS. Okay. Now the second question is area of AXS. Okay. So area of this triangle AXS. Okay. So this is the triangle AXS. So the area of AXS is equals to half of PQRS we have to prove. Now where is this triangle AXS? It is in the parallelogram ABRS. Okay. Now this AS is parallel to BR. Okay. So we know that the area of a triangle is equals to the half of the area of a parallelogram if they are between the same parallels, that is AS and BR, and in the same base, that is AS. So we can write the area of AXS is equals to half of area of ABRS. Okay, ABRS. Okay. Now this area of ABRS is equals to area of PQRS. Okay. So in place of ABRS we can write half of area of PQRS. All right, because the area of these two parallelograms are equal, and we have already shown that. Okay. So this is quite simple problem. We have now a theorem, and according to this theorem, two triangles on the same base or equal base and between the same parallels are equal in area. Okay. So, two triangles on the same base. Okay. So, these two triangles ABC, okay. This is one triangle and other triangle is DBC, this one. Okay. So, they are in the same base BC. BC is the common base for both of these two triangles. Okay, and between same parallels. Okay, so AD is parallel to BC. Okay, AD is parallel to BC. Okay. Now, we need to show that the area of this ABC is equals to the area of DBC. Okay. So, how we are going to show that? First of all, we need to do some construction for that. Okay. So, parallel to this line AB, from the point C, we have to draw another parallel. Okay, CF. All right. So, first construction is AB parallel to CF. So, why we are drawing the parallels? Because we have two theorems already, that the area of parallelograms. Okay. So, area of two parallelograms between the same parallels and in the same base are equal, and the second one is the area of a triangle is equals to the half of the area of a parallelogram if they are in a same base and between the same parallels. Okay. So, anything to show this kind of things, we need to have parallelogram. So, to construct the parallelogram ABCF, we need to draw the line AB parallel to CF. Okay. So, this is kind of one technique. Okay. This is one technique, like the construction, whatever construction you have to do based on the theorem what you have. So, the theorems what you have, based on that you need to do the construction. Okay. So, we have the chapters like circles, triangles, any kind of chapter, whatever theorems you have, do the construction based on that theorem. So, here we have parallel. Okay. So, we need parallel. So, we are drawing the parallels. So, CD parallel to B. So, we need to draw CD. Okay. This CD here, this side, we need to draw a parallel BE. Okay. So, by drawing the parallel BE, we constructed this parallelogram BCDE or EBCD. Okay. That is why we are drawing these two parallels, this one and this one. Alright. So, we have the theorem, since we have drawn these two parallels here, we have the theorem that parallelogram between the same parallels and in the same base, their areas are equal. Okay. So, here we have the parallelogram ABCEF. Okay. We have the parallelogram ABCF, and we also have this parallelogram. Okay. BCDE. Okay. BCDE. Alright. We have these two parallelogram. Alright. Since they are in the same base BC and between the same parallel, okay, between the same parallel and in the same base, so their areas will be equal. Okay. Alright. Now, we know that if a triangle and a parallelogram are in the same base. Okay. So, here in this parallelogram BC, in this parallelogram BCDE, okay, in this parallelogram we have the triangle ABC, we have this triangle. Okay. So, in this parallelogram BCDE, we have this triangle ABC. Okay. So, since they are in the between the same parallel ED, and BC, and in the same base BC. So the area of ABC, so the area of ABC, triangle ABC is equals to half of the area of BCD, all right. Okay. So let's take this equation as 1. Similarly, in this parallelogram ABCF, in this parallelogram ABCF, okay, in this parallelogram ABCF, we have this triangle, okay, we have this in this parallelogram ABCF, we have this triangle DBC, okay. So we can write here area of this BCD or DBC, area of BCD, that is this triangle is equal to half of area of BCF or ABCF, okay, ABCF, okay. Let's take these equations 2, all right. This is 1, this is 2, okay. So from equation 1 and 2, we already have that area of ABCF equals to area of BCDF D, okay. So from this equation we can put the value of ABCF here as BCD, okay. So this side is equals to this side. So area of ABC, area of this triangle ABC is equals to the area of this triangle BCD, okay. So from 1 and 2, okay. So if we take this as 1, this equation as 2 and this equation as 3, from 1, 2 and 3 we can write the area of this triangle ABC is equals to the area of this triangle BCD, okay. Here we have a question, okay. So here in this figure, is any point on the median AD, okay. So this is triangle ABC, okay. So AD is the median, okay, that is the D is the midpoint, and E is any point on this median AD, okay. We have to show that the area of ABE, we have to show that the area of this triangle ABE, this triangle is equals to the area of the triangle ACE, okay, that we need to show, all right. So here what concept we will use? We have median, okay, median. So what is a median? Median, that from any point of a triangle, if we draw a line, okay, which divide the line opposite to the point into half, okay. So here BD equals to DC, so this is the median, okay. So go to just check the definition of the median, but whatever, but we know that the median of a triangle divides the triangle into two triangles of equal area, all right. So if we have any triangle like this, okay, ABC, so if we draw a median from C also here to the midpoint, all right, okay. So it divides the triangle into two triangles of equal area. So equal the area of this triangle will be equals to the area of this triangle, okay. So here, since AD is the median of triangle ABC, we have area of triangle ABD, area of ABD is equals to area of ADC, all right. Similarly, the same median, so this is the median for this triangle EBC also, okay, and still because this is the middle point, okay. So we can write the area of this triangle is equals to the area of this triangle because ED is the median, okay. So we can write area of EBD is equals to area of this triangle EDC, all right. So let's take this as 1, this as 2, Okay. So, if we now do 1 minus 2, equation 1 minus equation 2. Okay. So, what does the equation says? One says the area of this triangle is equals to the area of this triangle. Okay. Now, what does the second equation tell us? The area of this triangle is equals to the area of this triangle. Okay. Okay. This triangle is equals to the area of this triangle. Alright. So, if we do 1 minus 2, this is equation 1, this is equation 2. Okay. If we do 1 minus 2, that is what we are doing basically, we are subtracting the area of this whole triangle. Okay. So, from the area of this whole triangle ABD, area of ABD minus area of EBD. Alright. So, from this triangle, the area of this triangle, we are subtracting this triangle, area of this triangle. Alright. So, what after subtracting this, what we will get? The area of ABE or AEB. So, similarly, this side, if we subtract the area of the whole this triangle from this, the area of this triangle, if we subtract area of ADC minus area of ECD, will get the area of ACE or EAC. Okay. So, basically that thing we are doing. So, from 1 minus 2 we will get the area of this triangle. Okay. This triangle will be equals to the area of this triangle. All right. So, this is done here, 1 minus 2. All right, 1 minus 2. So, area of ABD minus area of BED, area of ACD minus area of DEC. So, finally, we will get area of ABE equals to area of AC. This is also a similar problem here in a triangle ABC. Here ABC, E is the midpoint of median AD. So, if AD is the median here, okay, so E is the midpoint. So, in the middle here, E is the midpoint here. Okay. So, we have to show that area of BED, this triangle is equals to half of 1/4 of area of ABC. Okay. So, what we need to show? Area of BED, okay, for this triangle is equals to 1/4 of area of ABC. Okay. So, here this is quite simple. This is the median of triangle ABC. We can write area of these two triangles ABD equals to area of this triangle ADC, because AD is the median. So, we can write area of ABD equals to area of ADC. Alright, because the median divides the triangle into two triangles of equal area. So, area of this triangle is equals to the area of, alright. Now, since E is the middle point of AD, so BE is also a median of this triangle ABD. Okay. So, this is also a median of this triangle ABD. Okay. So, this triangle ABD, since E is the midpoint, so BE is the median of this triangle. So, we can write area of these two triangles are equal. Area of ABE is equals to area of BED. Alright. So, since the area of these two triangles are first these two triangles are equal, okay, this triangle and this triangle are equal, we can write the area of this triangle ABD. Okay. So, area of this triangle, area of ABD is equals to half of area of ABC. You can write area of ABC, okay, because the area of this triangle and this triangle are equal, okay. So area of this ABD is equals to half of area of the whole triangle ABC, okay. So in ABD triangle we can write, since BD is the B is the median, so here we can write the area of BED, because we have shown that the area of this triangle is equals to the area of this triangle, alright, since B is the median, okay. So in place of BED, in place of ABE, we can write here in this equation, we can write area of this triangle EBD, okay, this triangle, interior triangle, equals to half of area of this whole triangle ABD, alright, area of ABD, okay. So we have the area of ABD equals to half of area of ABC, okay. So in place of half of area of ABD, we can write half of area of ABC, okay. So if this is equations 1 and this is equation 2, alright. So putting the value of equation 1 in equation 2, what we will get? We will get something like half of, okay, into half of area of ABC, okay. So half into half means 1 by 4 of area of ABC, okay. So area of EBD, that is area of EBD is equals to 1 by 4 of area of ABC, okay, alright. So proof is already given here, alright. Here in this problem, we have to show that the diagonals of a parallelogram divide it into 4 triangles of equal area, okay. So PQRS is a parallelogram and diagonals PR and QS. We have to show that the diagonals PR and QS divide this parallelogram into 4 triangles of equal area, okay. So what we need to show? We need to show that the area of this triangle OPQ equals to the area of this triangle, okay, OQR, this triangle ORS, alright, and this triangle OPS or OSP, okay, alright. So we need to show that the area of all these 4 triangles are equal, okay. Then if the area of these 4 triangles are equal, then we can say that the diagonals of a parallelogram divide it into 4 triangles of equal area, okay. We know that the diagonals of a parallelogram, okay, so bisect each other, okay. So these two are S, Q and PR, these are the diagonals of this parallelogram PQRS. So they bisect each other. So this point PO equals to OR and OQ equals to OS, okay. Again we know that since they bisected each other, okay, so why we are saying this point that they bisect each other, this length is equals to this length, that means what? O is the midpoint of SQ, okay. So if we consider this triangle SPQ, okay, so if we consider this triangle or PQR, okay, any triangle if we consider, then this O is the midpoint of their base. So that means what? These are also the medians of the triangle SPQ. This is also the median, OQ is the median of PQR, triangle PQR, okay. So these are nothing but medians of these triangles, alright. So we know that the medians of a triangle divide the triangle into 2 triangles of equal area, alright. So here we can show that the area, since O is the midpoint of SQ in the triangle, okay, you follow that figure, I am just showing it for your understanding. So in this triangle SPQ in this triangle, okay, in this triangle, since O is the midpoint of SQ and POP is the median, so the area of this triangle will be equals to the area of this triangle. Okay, so we can write area of SOPS or POS, anything OPS, okay, is equals to area of OPQ. All right. So area of these two triangles are equal. So similarly, in this triangle, if we consider this diagonal, in this triangle, okay, in this triangle, O is the midpoint of PR, okay, and OQ is the median of triangle PQR, okay. So in this triangle PQR, since OQ is the median, so the area of this triangle will be equal to the area of this triangle, okay. So we can write here in PQR, in triangle PQR, area of OPQ is equals to area of OQR, all right. So similarly, we can again consider this triangle, and here also we can show that the area of this triangle and this triangle are equal, all right. So ultimately we will get that the area of, since from these two equations only we can show that OPQ, okay. So in place of OPQ we can write area of OPS equals to area of OQR, all right. That means OPQ. So we already shown that the area of all these three triangles are equal. Similarly, we can show that this the area of this triangle is also equal to this triangle, all right. So ultimately, we can prove that area of these all four triangles are equal, okay. So that is the point here. The main technique is, since the diagonals bisect each other, diagonals of a parallelogram bisect each other, and O is the midpoint, so these are the medians, okay. So medians divide the triangle into two triangles of equal area. So that is the main technique you have to use here, okay. In this question, so ABC is a triangle and DEF are the midpoints of the sides AB, BC and CA, okay. And if we join them, we will get a triangle DEF triangle, okay. So here what we have to show? We have to show that this BDEF, this is a parallelogram, all right. And we have to show that the area of any triangle, of a triangle FBD or DEF, okay, here this triangle DEF, okay. So area of this triangle is half of the area of the parallelogram, okay, half of the area of the parallelogram, okay. So here it is wrongly written. So what we have to show that area of DEF, okay, area of this triangle is equals to half of area of the parallelogram BDEF, all right. So how we are going to do that? Here one theorem you have to remember, like earlier we did one that theorem, like if any triangle, in any triangle ABC, okay, if any triangle ABC, if we draw a line by joining the midpoints of two adjacent sides, okay. So suppose D and E are the midpoints of the sides AB and AC, okay. Then the length of DE will be half of the length of BC, okay. So we already did this theorem, okay, we already had it earlier chapters, okay. So in geometry, any theorems, those are related to triangles, quadrilaterals, parallelograms, okay. So it's not like that in one chapter you have certain theorems and you can apply those theorems also only, it's not like that. So all those theorems, like in chapters, like 5 chapters are there, all those theorems if applicable, if they are related to, since this is related to triangle and parallelogram, they are applicable. Okay. So, you have to know how to use them. So, here we can apply this theorem. Okay. By applying this theorem, we can show that this BD is equals to EF, all right. So, similarly, this side equals to this side. If we can show that, then we can from that we can prove BDEF is a parallelogram. Okay, all right. So, here ABC, ABC, four side this the midpoints. Let's join the midpoints DEF. Okay. Now, since EF, E and F are the midpoints of AB and EC, therefore, we can write EF or FE is parallel to BC. Also, EF is half of BC. All right. I already told you, joining the midpoints of two adjacent side, half of the third side and parallel. Okay. Similarly, we can since this EF is parallel to BC, since EF is parallel to BC, okay, this line is parallel to this line, and D is the midpoint of BC, okay, we can write EF is parallel to BD, okay, and this half of BC means equals to BD, since D is the midpoint. Okay. So, we can write EF equals to BD. Okay. So, this EF is equals to BD and EF is parallel to BD. So, similarly, we can show that BF is parallel to DE and BF equals to DE. All right. So, similarly, we can show that this line is equals to this line and they are parallel. Okay. So, here we have shown that these two lines are equal and parallel. Okay. So, therefore, BDEF is a parallelogram. All right. Now, that is the third part we have proved already. So, here now we know that the diagonals of a parallelogram divides the parallelogram into two triangles of equal area. Okay. So, here we have this parallelogram BDEF. Okay. We have this parallelogram, okay, and DF is the diagonal. So, the area of the parallelogram BDF is equal to the area of the parallelogram DEF. Okay. So, this sorry, not parallelogram, triangle. So, area of this triangle will be equals to the area of this triangle. Okay. So, in the parallelogram BDEF, since FD or DF is the diagonal, so it divides the parallelogram into two triangles of equal area, that is FBD or BDF and BEF. Okay. So, here we can write area of BDF equals to area of DEF. Okay, DEF. All right. So, area of BDF, area of DEF. Okay. So, area of BDF means what? Since the area of these two triangles are equal and they are and we can write that area of BDF plus area of DEF equals to area of BDEF. All right. So, in place of BDF, we can write DEF only. So, 2 of DEF means DEF plus DF, 2 of area DEF equals to this one area of BDF. That means area of DEF equals to half of area of BDEF. Alright. So, that is the thing we have to prove. So, area of DEF is equals to the half of area of this parallelogram BDEF. Okay. So, we have proved that area of triangle DEF is equals to half of the area of BDEF parallelogram. Alright. So, that is how you need to apply your concept, apply those theorems to solve this kind of geometrical problems. Okay. So, students, today we did the problems in the chapter area of parallelogram and area of triangles. So, you have to apply the concept, apply those theorems whatever you have here, and do practice all these related problems. In the next class, we will have some other topics, we will have some other geometrical problems, and till then, thank you.